Okay. Thanks, Cliff. Hello, everyone. Good afternoon. This is Charlie. Thanks for Cliff to invite us to have this talk on the Hyperledger Sydney meetup. This is really we had a meetup last month in March to introduce Hyperledger Indy and give a bit overview of how in Fabric we are using Hyperledger Indy in our application. So this is really a further add up to that meetup. So I'll go to the next slide. My name is Chi Zhang. So I'm the digital asset technology lead in Fabric. You can contact me on the LinkedIn. So just search Chi Zhang on the LinkedIn or scan the QR code using your mobile. So that's the agenda for today's meetup. So I will run a quick introduction of Hyperledger Indy. Whoever attended the last meetup, so please bear with me. You probably already seen some of the contents there. So because this is just for kind of catch up on the meetup we did last time. And then just to further elaborate on the give you that idea how we could use Hyperledger Indy for a health code application. So I will do the quick intro of the Hyperledger Indy, and then Kaiyang will run a quick intro of how we use Hyperledger Indy in Fabric, and then he will also introduce the health code application widely used in China, and propose the ideas how we could use Hyperledger Indy for a similar app, and then me and Kaiyang will run the ideas to applying the Hyperledger Indy for that app. Yeah. So I will quickly run through the Hyperledger Indy. So Hyperledger Indy is a suite of tools, libraries, and reusable components based on the blockchain technology to provide digital identity for different applications, and also can be interoperable across different domains, blockchains applications. To use one solution for the self-sovereign identity application. You can find out more details about Hyperledger on the URL at the bottom. There's famous user cases, at least two. You can go have a look on Sovereign web page. One of the notable use case I just found out recently. How spell that? The true ID. This is a UK company, so they are using Hyperledger Indy to issue the credentials for the healthcare staff. So they are working with the UK NHS and the post office, so that the post office can issue verify the identity of the NHS service staff, and then issue the credentials, and then and then the NHS staff can use that as a verifiable digital passport to enter into the premises of NHS buildings facilities. So that's one kind of notable application, and also is used by the governments of British Columbia, Ontario, and Canada to build they call it the verifiable organizations network to issue company credentials and the registrations. So you can have a look of those use cases for the Hyperledger Indy. So in terms of the kind of the features of the Hyperledger Indy. That Hyperledger Indy trying to build a verifiable credential ecosystem. This is, three main type of users or main roles in the Hyperledger Indy verifiable credential ecosystem, namely the issuer, the holder, and then the verifier. And then, on top of the public blockchain or the decentralized network, there's a unified identifier, the DID, the decentralized identifier. So the issuer, holder, and the verifier, they all have their own DIDs. Then the issuer can send the credentials to issue a zero-knowledge credential to the holder. The holder then countersign the credential and save in a local wallet. For example, in a mobile app. And then during the verification phase, the holder presents the credential. Take out the credential from the wallet, present the credential, the zero-knowledge proof credential to the verifier, and then the verifier can verify the signatures of the issuer and then the holder. So that's how it works. And then the issue credential and presence credential, those activities are actually executed off-chain. So on-chain, also there's in the next slide, I will show what type of information will be stored on the ledger. The main components of the Hyperledger Indy are the four main components. The first I mentioned already, the decentralized identifier. So each user can have one or many kind of decentralized identifier generated. Then the next components is the verifiable credentials. So it's kind of type of JSON data the issuer can create by using sort of a template. We will show you the template later in the meetup as well. And then those are the kind of the data, and then the kind of the players or the users actually on the Hyperledger Indy ecosystem are they call the agents. The agents communicate with each other peer to peer, and then to support creating the relationships and share the credentials, and also issue verifying the credentials as well. And then the kind of the infrastructure itself is the distributed the ledger. So only four types of data stored on the ledger itself: the public DID, the revocation registry where the issuer can revoke the credential, and then also the schema and then the definitions of kind of type of JSON data stored on the ledger. So here I will show you quickly an example of this schema. So it's a JSON of data, and then the main thing you notice the red highlighted attributes. So you can specify the attributes you want to create, the definition and the credential for which attributes, or maybe the last name, first birth date, something you can issue the credential or the actual attribute value for that schema, and then the by using the schema for the different issuers. So the schema used to be as a template across the different issuers. So different issuers can issue can create their own definition. We'll use this as an example later in our case, in our health code case. So different issuers can create the different credential definitions linked with a schema ID. So, and also both the schema and then the definition will bear the public DIDs for the issuer. So that's schema and the definition. So this is kind of high-level overview of the Hyperledger permission Indy network. So in the core are the validator pool, which is a bunch of the nodes running independently on the cloud, and then the middle layer they call observer pool, which only have the read permission. So the observer nodes can only read the data from the ledger, cannot write. And then the outer layer, the agents are the agents we talked about before. So the agents act as the proxy for the mobile devices like a mobile phone, a pad, or also laptop, desktop, to connect to the agent to perform the actions of sharing credential, retrieving the credentials. So the last slide I want to show you is the Hyperledger Indy concept of self-sovereign identity SSI standard. So there's kind of four layers in that standard from the bottom, and the layer one is about the public public blockchain, and then the ledger DID itself. So that's the infrastructure, and then the next layer, the agent-to-agent protocol. That's the agent and the wallet. They communicate with each other. So those two layers compose of the identity meta system. So this layer is more about standard and machine communication protocols. Then the kind of the top half of the layer is kind of more about trust and human interactions. Then you have the three roles I mentioned before: the issuer, holder, and verifier. They have the verifier. In order for the verifier to verify the credentials, the verifier has to trust the issuer, and then the holder talk to the issuer and the verifier off-chain as well. And also there are several roles in the standards which can dictate. The trust anchor has the role to be able to issue the credential, and you have the governance authority in the previous slide. I showed you the network, to governance the who can write the data, who can read the data. So this is all these layers compose of the whole SSI standards of the Hyperledger Indy. So that's just give you a quick intro of Hyperledger Indy. Give you a flavor of how it could be used, and also for Hyperledger Indy is composed of two layers: the unledger layer, DID public blockchain data about the schema and definition, and also the off-ledger or off-chain layer. Among the three players, holder, issuer, verifier, they have to communicate with each other off-chain, and then to do the verification and retrieving the credentials offline. So those are the quick intro of Hyperledger Indy. So I will then pass to Kaiyang to give you an intro of how we use Indy in Fabric and then the house code.
Yeah, okay. Thank you, Charlie. Thank you, Charlie, for introducing us about the foundation of Indy, and thank you a lot for Click to initialize this meetup. Okay, so hi everyone. My name is Kaiyang Pan, and I'm currently the blockchain technology researcher at FinFabric. I joined this fantastic team last year, and we are currently working on CrossPool. And in this meetup, we actually we used Indy before for our project CrossPool. Recently, we figured out that Indy can be definitely fit with the health code project. Hence, in here, this meetup, we want to propose an idea here of health code for further discussion. Next slide, please. Okay, so let me give a very brief introduction of CrossPool. So CrossPool is an enterprise solution for private market institution to establish standardized workflow, CrossPool application layer provides business and institutions a friendly UI to tokenize their company shares, debts, assets, and manage due diligence with third-party KYC service providers. So how we use Indy in our CrossPool system? So for example, as an investor on CrossPool, generally speaking, you will need a permission from issuer for you to invest or trade the asset he issued. So for approving your permission, due diligence will be conducted, and you need to submit some of your information like passport ID, date of birth or gender, and a KYC service provider will produce a due diligence report based on the information you provide. And this report will be sent to the issuer for their reference of permission approval. So also in CrossPool system, different asset might need different credential, even with the same issue. Let's take a look of our example here. And user account will have several key pairs controlling different DIDs. A KYC credential will be issued by asset issuer for specific asset like company share or gold bars or paintings here. And this credential will be bound with the investor's DID. With this KYC credential, investor will be eligible for investing these assets. More than that, CrossPool also built a secondary market for private assets. Different decentralized identities with the same type of confidential will be eligible to trade tokenized asset based on top of recording contract. Recording contract here, we mean a format of digital contract holding legal proofs and code, and it's actually protected by crypto signatures. Next slide, please. So how we actually do this in CrossPool system? CrossPool architecture itself is actually a dual blockchain system which utilizes Indy as decentralized identity management layer and Corda as the distributed ledger for digital workflow. An institution or business who is running a CrossPool application layer will launch a website powered by CrossPool with abundant functionalities. According to our decentralized context, account and user management will be controlled by Indy network to make sure real identities while keeping user privacy. Corda will in charge of transaction ledger to empower tokenization, asset trading, and digital contract signing. A KYC workflow will only happen locally on CrossPool application layer hosted by institution, and non-sensible data like credential definition and others will be synced to public Indy network. So how a transaction runs through CrossPool and how a KYC workflow works. Assuming that we have a token transfer from one institution client to another one, step one, so the token will be transferred to an escrow account in CrossPool-based layer, and respective credential will also be sent to a CrossPool base. And the second step will be the credential will be sent to Indy network for verification. And the last step will be once we get approval from Indy network, this will trigger token transfer from escrow account to a target account. Yeah, like this. Next slide, please. So how we going to apply the idea of Indy into the example we wanted to have here, the health code, or in our current coronavirus situation? We're going to follow this graph to explain more on our idea. So first of all, it's assuming that we are an individual that we need some credential for us to entering a restaurant and in this coronavirus situation. So an individual will have his identity child, In this case, it's actually, in the case of our PPT, it's actually the physical appearance, name, and job title. And in the case of coronavirus, will be, for example, like a nucleic acid testing report. And this report will be recorded and uploaded as a child for an individual. So for the authority like an hospital can review and examine this nucleic acid testing report and hence produce a proof of this report. The individual can then claim this proof by submitting forms to, and the hospital will issue a credential according to his forms. It's the claim step here. And finally, the verifier, like a restaurant, can verify our credential and allow us to dine in without knowing more of our private information. Next, please. So let's take a look of what's happening inside China. So as we know, QR code is actually widely used in different areas like payment or identity verification and etc. So to obtain a health code, citizens have to fill in their personal information, including their name, national identity number, passport number, and phone number on a sign-up page. They are then asked to report their travel history, whether they have to come into contact with any confirmed case or suspected case in past 14 days. They also need to tick a box for any symptoms they might have, like a fever, fatigue, dry cough, stuffy nose, runny nose, and etc. So after the information is verified by authority, each user will assign a QR code in red, amber, or green. Within a week of offline, excuse me, Charlie?
Yeah.
Yeah. Can you just try to mute your
Okay. Yeah. Sure.
Okay, so go back to our QR code. So citizens will be required to report their symptoms like a fever, fever, fatigue, dry cough, or anything else. So after this information is verified by the authorities, so each user, each citizen will be assigned a QR code in either red, amber, or green, which means confirm or danger, or middle danger, or even safe. Within a week of this launch, actually, the Alipay health code will roll out in more than 100 cities across the country. So here, what we wanted to propose is like, Indy solution is not actually, is not an alternative solution. We're following the same idea of utilizing QR code and Indy to provide a convenient solution for identity management in current situation. Next, please. So for why we use Indy actually, so Indy will be quite easy and important. It's actually a portable with self-sovereign identity and temper-resistant cryptographic credential, and the most important is so sensitive data protection by zero knowledge proof. Let me give a very quick example of this zero knowledge proof. So saying that the authority or the verifier will be interested in your past experience or some of your information, like whether you are older than 18, and the zero knowledge proof will give out an answer, will turn out to have an answer like yes or not, rather than revealing your real age. So in current situation could be the verifier will ask the authority whether this guy have ever been to or have ever physically contact with a confirmed case, and the authority will answer saying that no, without reveal any of your information like past or past or checking your past routine. So what we're trying to propose here is like Indy actually provides us a better privacy protection in this situation and in this idea. So next, Charlie will introduce the workflow of the idea we're going to propose. Charlie, please.
Okay, thanks, Ken. So I will run through quickly the ideas or the workflow we can do to build a possible solution or app for using Hyperledger Indy. So this is roughly the workflow. As I mentioned, we have the different roles or players in the Hyperledger Indy verifiable credential ecosystem. So in our case, for example, the first step might be a government to publish or announce a public acceptable Indy credential schema for attesting for a hospital, either molecular testing result or the antibody test, whatever the kind of public acceptable schema. Then for each, as I said mentioned before, because the Hyperledger Indy, once you have the schema, then each individual issuer can generate their own credential definitions by using their own DID. So basically, each hospital or each issuer could have their own DID issue the definition. So once the definition generated from the schema combined with the Indy, they call it the credential offer. So the credential offer, you use an analogy, sort of like the application form when you enter into the hospital. You need to fill out the form. So that's the template of the form, the credential offer. Then the hospital can use present a QR code for the users to scan the QR code to retrieve the offer. So initially we thought we can embed the whole offer into the QR code, but then later we found out the credential and then the offer, the length of the string, the length of data might be quite huge for just a QR code is several thousand characters. So we could have an agent or proxy that can temporarily save the data, which could be encrypted by the DID, because the DID generated by the private public key. So you can encrypt the data using the counterparty's public key, and then the proxy or the agent can just use it as a middleman to pass around the data, and then you as the DID holder or private key owner, you can decrypt that data. So that's a further kind of implementation detail. Then once you have the QR code, then you can take out your mobile, scan the credential request template, and then you generate the credential, they call it credential request, the Indy credential request within your mobile to fill up some of the personal data required. Maybe your passport number, or your national ID number, your communication, contact details. Then you encrypt the data and then send back, and then you can also present that QR code on the mobile for the doctor or nurses in the hospital to use to scan to retrieve the credential, the request credential back. And then once the test, either the molecular test or antibody test passed, then the hospital can issue the credential. Then the credential can be a QR code, sent to your email, and then you can use the mobile to scan the QR code to retrieve that, or you can scan from directly get the credential from the mobile app if the app can also to be the proxy of the data handler. So that's the credential issuing workflow, then come to the verification workflow. So then on the right hand side, when you as a person you want to enter into a public premises like airport or like public building, then the guard of the or the management company of that facility can can retrieve the credential definition and then present a Indy proof request QR code. So this is another concept of Indy called the Indy proof request. Then so the request is just for that particular the person. So that person scan the QR code and then get the request and then generate the Indy proof using the credential saved in that mobile, and then send the Indy credential proof back to the guard of the building, of that facility. Then the guard can either scan the QR code or maybe from the computer to get the data and verify the credential on the Indy network to use the zero knowledge proof to check if the test has been passed or not without reviewing too much information. So those either the kind of the proposed workflow we can do to build a Indy-based mobile app, and also the potential users of these could be the testing institutions or hospitals, and also the facilities which control the people to enter into that. And then the next one, I will show you some code example. Let me stop this and then share some of the code. Okay. So hope everyone can see kind of this testing code of the Indy itself. We haven't finished all the kind of components because that's going to involve different server side applications and the mobile. But then this is just a quick run through of the workflow I mentioned. I introduced before. For example, in here, assume we have the government. Then the government can use the Indy to create the wallet, and then maybe it's too small. Let me show that bigger screen. Okay, so then the government can create the a Indy credential schema. So in this case, in this test case, so I just use 3 kind of attributes, which one is the email, and then is the next one is the pass the result, either pass or fail. Then the third one is expired time. So when you do the test, maybe it's valid for 1 week, then you should have some valid date. So assume the government create this schema and then publish that schema onto the Indy blockchain. Then comes to the next step. So we have one hospital. The hospital, they created the wallet and then created the ID. Then the important thing is to create the definition. So the Indy call. This is a SDK. Well, by the way, there's on the Indy GitHub repo, you can download the different SDKs for JavaScript, Java, and Python as well. So I'm using the Kotlin code, which using the kind of the Java SDK. So in that one, you can create the Indy issuer can create and store the credential definition, and then publish that definition onto the blockchain. And then the next one, so the issuer can create a credential offer. Then from here, the issuer can publish the offer, send the offer data to agent or proxy. Then the proxy or maybe a trusted service provider can generate a QR code for the user to retrieve this offer. And then the next step, so assume a normal guy, John, came in. So John has the mobile app, so he can create the wallet and the DID. The DID and then the wallet in the mobile, and then fill up the information of his email, then send back to the hospital. So the John retrieved the offer and filled up some of the information, sent back to the hospital. Then here, one information, for example, the email, the issuer can, sorry, not the issuer, the holder, John, can fill up. And then for the pass result, then the hospital can say, okay, 1 represent pass and 0 means failure. And then you can, then here I do a testing, so for current time plus 1 day to be valid for this credential. Then in this case, the hospital fill up the pass and the expiry information, and then created the credential. Then sent to the third party or the trusted service provider sent back to John, and John can save that or scan the QR code and then save that data into the mobile, the mobile app. Then we'll come to the verifier part. So the same as before, you can have for example, the airport. The airport can create the wallet and create the DID. The main thing here I want to show you is quickly is the airport create the proof request for the Indy request. You will notice, we mentioned before, for the zero knowledge proof in Indy, how Indy implement that is in the data, the proof request, you can have this called a predict reference, which you say, okay, I don't want to your real data. I just want to say, your attribute pass is greater than 0, and also I want to verify your expire time is greater or equal than the current time. So if the airport generate this proof real time, then then it will generate this proof request immediately, instantly, and then send the data somewhere, then present a QR code. Then the John take his mobile, scan the QR code, and get this proof request. Then the John will in the mobile app, the John will call another Indy SDK call saying Indy proof or fetch credential for the proof request. Yes, another one I forgot to mention. In the proof request, the verifier need to specify which credential definition ID they trust. Now remember, I mentioned before the 3 players, the 3 roles, holder, issuer, and the verifier, they have to trust each other. And so here the verifier will specify which definition ID they trust. Maybe it could be a list of white list of IDs they trust, and then they generate the different proof requests for the users to scan. Then the user fetch according to the definition ID, fetch the credential, the pre-issued credential from their mobile, and then fill up the data for the predicts of the pass and then the expire. Then finally, John generated proof in the mobile app, and then send the data and present the QR code. Then the airport can scan the QR code, get the proof to do a zero knowledge proof, just to verify, as I mentioned before, the pass has the value greater than 1 and the expired time is greater and equal than the current time. So this is just quick run through of the workflow and then the possible implementation of the Indy code. So in terms of the real implementation, I think it's in here we don't propose any kind of solution because there are a lot of arguments there for a proper schema. You should maybe it's a schema for a molecular test or for antibody test, which part of the kind of attributes you should verify, you should test. That's kind of out scope of this chat or conversation. So here, like the Chinese all saying, we want to just throw some stones to attract jays. To propose maybe better use Indy, the self-sovereign identity for privacy protection, and also the portable credentials to be used for issuing. I mean, it's not only for issuing tests; it could be also issuing other credentials which can be verified in real time, instantaneous using the mobile app. Yeah, so I think that's all we want to share during this meetup. So the next one going to be the questions to Q&A. So if you have any questions, we can discuss here. Otherwise, we'll just stop here. So I think, yeah, just Q&A now.
Thanks, Charlie and Kaiyang. So any questions so far?
I have a question.
Okay. Yeah.
Hi. My name is Lawrence. Have you thought about any other possible issuers for these credentials? I mean, the governments or the hospitals or the clinics who issue to verify the fact that a person has passed certain tests might be one example. But what about other cases? Have you considered proofs about the person's location or maybe travel history?
Yeah, I had a thought. It could be used for other cases. I don't know, anyone of you have heard of the recent story about Apple and Google. They are trying to build to work together to build an app to use the Bluetooth API communication to track of a person. Then they mentioned in their technology they are using a random rotate kind of key thing. In that case, I think we could implement Hyperledger Indy as well to use DID for generating DID randomly and using the DID as the random key. So you can, because for the way go back to the implementation we have done here in Fabric, how we generate the DID is the same as we are using for the Bitcoin wallet. We use the HD, the HD wallet, hierarchical deterministic wallet. So you can have one password. Then you can literally generate a limited random numbers of random the DIDs are limited. So you can use that way to generate for every period of time you randomly generate a DID, use DID as the key, using for that kind of tracking personal, tracking app. But not only for that, your day travel track, but you can also issuing some credentials based on the DID without revealing your identity. So you can have a DID maybe same as the Chinese government does. When you enter into a public, say airport, or you travel by a train, then you can once the guard scan your DID, then they could issue a credential saying, okay, you entered the premises, or you used this you fly with this flight number, blah blah, and maybe the train. Then, in case there's a positive case with the same travel history as yours, then the government can publish that case using the DID, not the real identity, and then you can you as the DID bearer, you can be notified just using the DID. I think that there's going to be a lot of kind of these use cases, as I mentioned before, for the for the true .id use case. They use Hyperledger Indy for issuing the NHS staff credential as well. So I think there are going to be a lot of these use cases applicable for the Hyperledger Indy.
I see. So that's actually very interesting. I mean, just to make sure that I completely understand what you're saying, the idea is to generate unlimited number of DIDs using the same password, and then so that people can't track you. So so you have perhaps one DID for each location record. So let's say I go to the airport, I boarded out on a plane, I will be recorded using one DID, and when I go to a different location, then another company will be recording my presence using another DID. So people can't actually trace my location history. But if there is a confirmed case of COVID-19, and the establishment can contact me in using the platform about that case, and then I might be notified that way. That's actually a quite interesting use case.
Yeah, I think one of the reasons the Hyperledger or the Sovereign Foundation they promote Hyperledger Indy, and then also they recommend that for different credential you use the different DID, so that the different issuers or different verifier, they can't work collaborate or in a way, or work together to figure out who is the bearer of that DID. So that that's one way of using DID. And then the DID is sort of combined with the credential, which means you sort of have revealed some of the information, the credential with one DID. So I think that's the best use case scenario for DID is you use different DID for different purpose, different credentials, or you just use as a random and random like a wallet address or a random key for different purpose, so that they can't all the even though the different players, different companies, verifier, issuer, they work together, they can't figure out who is real who is really behind the DID. And then but then you can sort of control the DID, because you only need one one private key, or one seed, or one password to control that.
Thanks for that.
Okay. So I will leave my email address in the public chat channel. So if you have further question, let me check the chat. Someone asked a question.
Yeah, there are a couple of questions in the chat group. So the first one is, why should we use blockchain here? Why not a centralized system, Charlie?
Yeah, so basically, as I mentioned, in this case, the blockchain or the Hyperledger, the ledger itself is not holding all the information, but some of the information, for example, the DID, the schema, definition, and the revocation, especially the revocation registry. So this is those 4 pieces of data are saved on the blockchain, which are immutable, which have all the blockchain features, immutable, cannot be changed. Those are important. But then for the credential itself, credential data, proof data, as I said, those data are not on the blockchain. So it could be centralized saved, or could be just off-chain communicate or transfer via the Bluetooth communication or other ways of the communication. So there's no limit of that. Using blockchain, it's just to make sure the definition itself, the schema, and then the revocation. If you are the user, you want to revoke the credential you issued before, you want to place that the data are trackable, immutable, and has the trust and authenticity of that. So that's why use the blockchain just for that purpose. Yeah.
That's right. Yeah, that's a brilliant part of the blockchain. So next question is, portable SSI sounds powerful, consenting sharing of info, and that will only work in a distributed, decentralized system, right? I think the answer is yes.
Portable. There's only work in a distributed, decentralized way. Yes, kind of like partly. The answer partly from my previous answer to the question why we use blockchain. I think when we say blockchain here, don't kind of misuse or understand the meaning of blockchain for the Hyperledger Indy. It's not the kind of same as the Bitcoin or Ethereum public ones. You save all the data onto the ledger. In here, only because the Hyperledger Indy the Hyperledger itself is advocates of the privacy protection. So only the public data, as I mentioned, the schema definition, the revocation registry, those are the public available, should be on a decentralized trust way of sharing the data without manipulation of one single centralized system. But then of the ledger, the credential is the credentials themselves or the proofs themselves are kind of like locally or off-chain data. So you up to the application developer to decide how your application to handle the data. One way we can do is that, okay, I'm the application developer, I can use the Indy with another blockchain like Coda or the Ethereum. So I could save some of the data, maybe the credential data itself, onto the Ethereum. Actually, I was thinking, because of I don't know if you have heard of the IPFS system. So IPFS system, think about like a blockchain database, can save the data, the kind of like the plant data. So if you want, you save the encrypted data onto the IPFS. Then that data is also on the blockchain, but it's up to the application developer. Then maybe as a private application, you don't want to share the data publicly. Then you can just hold information yourself as a service provider. Then you just pass around the data as an agent. So that's the answer. Yeah.
Okay, cool. Yeah, thanks
Yep.
for a lot of information. Next one, which Indy network are you using? Is it sovereign or WON or your private?
The Hyperledger Indy. So it's the software itself is open source software. You can download, you can run yourself. So in our case, for CrossPool, we build our own Indy network for our own purpose. But then the sovereign foundation, who is behind the Hyperledger, all these technologies, they have a public ledger, the sovereign foundation network. If you want to join, it's like a public Indy network. I think the two use cases I mentioned, the true.id and then the verifiable organization network, those are using the public sovereign network. So it's flexible. You can have your private or consortium or public blockchain or network.
Okay. So next question from Alex. He's asking, so you showed example, you testify, what if the airport will create a proof that they want to receive some data that I, as a person, do not want to share? How can I check this?
Yeah, I think that's a good question about the trust, and also about the self-sovereign identity. So the self-sovereign, because when I showed you the data, all these requests, and then the data standard or protocol are handled by the code itself. Then when the application or the app developer can choose to say, okay, once the airport asking a person to review more data, you can as a person you can choose to review, or you can decline. But then obviously, if you decline, you might be rejected by the airport. So this is not about the code or the Hyperledger Indy itself. Is about the sort of the relationship and trust between the airport guard and then the customer. So if all the people, they don't want to share more info, then the airport ask, then apparently then they won't get the customer in. But then you have I think it's important that you are as a user or as a real client, you are notified and you are aware that your data, even though you are forced to share the data, you are aware that your data, which kind of data are shared and retrieved by the verifier.
Okay, so we are about run out of time. Thanks for everyone. If any post questions, feel free to drop Charlie an email. Again, thanks for joining Hyperledger Meetup. See you guys next time.
Thank you. Bye.